Okay, we'll work through heat transfer quiz 1 for mechanical engineering 3250. We have a description that a family of 4 needs a new hot water heater. They estimate their usage to be 100 gallons of hot water per day. We have the incoming water temperature at 10 degrees Celsius. Due to some children being in the home, the thermostat set to 52 degrees C, which is just around 120 degrees Fahrenheit. And we're given some properties, so we don't have to look those up, as well as a reminder of some of the equations we will need. We're asked to calculate the energy required to heat the water to the specified temperature, and I should have been a little more clear in this, but I was looking for that on a per day basis, so like megajoules or joules value. I received some answers in watts, which is fine. I gave full credit for those. And then part B, they're evaluating between a tankless water heater, which won't have any heat loss when you're not requiring any water flow, and then a traditional tank, which will store some volume of water and lose heat throughout the day and need to be reheated. And we're told that the overall heat transfer coefficient for that water heater, the tanked version, is 1.2 watts per meter squared Kelvin, and that we approximate the exterior of the tank as 0.5 meters in diameter and a height of 1.5 meters. So we're asked to calculate Q for the temperature loss, or the heat lost from the inside temperature at 52 degrees Celsius, to the air temperature of 22. And we look for the Q for 1 day. And we haven't covered U before, so I'm telling you to use U like you use H for convection, and take the internal water temperature as the surface temperature. So we're just clumping a few things together there. And here's where we get our points. We get 2 points for the setup for our heat loss, 1 point for the answer, 1 point for our total heat, our energy requirement, and then 1 point for our energy answer. And then finally we're comparing that water heating due to heat loss to the actual amount of energy that's going into the water on a percent basis. So looking at part A, let's see, let's get my pen down here. So looking at part A, didn't specifically tell you you could do this, but if we're looking on a per day basis, we can do Q is M CP delta T, where our M is going to be 100 gallons, and 100 gallons is going to be, from our conversion sheet, which I gave you, it's going to be 264.17 gallons. Gets us 1 meter cubed. So we're meters cubed. So to get our volume, we need to, our mass, we need to do our density, 995.4 kilograms per 1 meter cubed. So now we've got gallons gone, we've got meters cubed gone, so we have our density, so we got our M, and we're going to multiply that by our specific heat, and this is the average specific heat around this temperature, so we have 4.186 kilojoules per kilogram Kelvin, and then our temperature difference is going to be our 52 degrees C minus our 22 degrees C. So Q on a joules basis is going to be 66.55 megajoules. So that's going to go to 66.6 megajoules. Which are 3 significant figures, and that's on a per day. And if we convert that to watts, we just have to do 1 day equals 1 day has 24 hours. I'm sorry, I'm doing this backwards. We have 1 day, 24 hours, 1 hour. You could break this down into minutes, but I recall offhand that it's 3,600 seconds. So if I do that, I get Q equals 770 watts. So some people had that value, and that's sufficient as well. So that's part A. Part B, I went a little too far. So we're told that we have some heat loss, Q equals UA delta T, or where delta T is T surf minus T infinity. I think that's how I gave that to you. Yep. T surface minus T infinity, not surroundings. So we have 1.2 watts per meter squared Kelvin times our area. We'll fill that in here in a minute, and our surface is going to be 52 degrees C. Oh, sorry, I made a mistake up here. This is not 22. This is 10 degrees C. But now we have our 22 degrees C. So our incoming water temperature is 22 degrees C, and we are heating it up to 52. So that was a heating requirement. This number is still correct. I just miswrote this from my notes. Our area for this guy, so we're going to have the top and the bottom. So 2 times pi d squared over 4 plus the perimeter is pi d, and then we're going to multiply that by our height, which is L. So all of that goes in here. We get 2 times pi times 0.75. Is that what I had? 0.5, excuse me. 5 over 4. So this guy's squared inside the bracket. Plus we have pi times 0.5 times 1.5. So our area is going to be, I left that inside there, 2.748 meters squared. It's a square. And our U is there, and this is 30. So our Q equals 98.96 watts. And then if I look at that on a per day basis, Q 98.96 joules per second, 3,600 seconds per hour, 24 hours per day. So Q is going to be 8.55 megajoules. So I could take that either way. I think I asked for both. It was a little confusing. I'll add units in the future so that you guys can know what I'm looking for. And then finally, part C, we're looking for percentage. It's to our heating requirement. So I'm just looking to take this number, the 8.55, over the 66.6. So you have 8.55 over 66.6, and that gets us 12.8%. So a couple common mistakes here were mixing up these time conversions. Other things were, again, a little confusion on big Q, little q. I think we covered that in class, so hopefully that's straightened out. But other challenges here were just realizing you could lump all this together. You could do this as a flow rate too, so 100 gallons per day, and finding that in meters cubed or kilograms per second flow rate, and then finding that in watts would be fine as well. But for the most part, people did fairly well, so I will conclude this video, and hopefully this helped clear up any of the parts that you struggled with in the quiz.